The following table gives data on normal time and cost and crash time and cost for a project. The indirect cost per day is rupees 10. So basically we have been given the various activities for the project, and we have also been given the normal time for completion of each of the activities. Now the normal cost has also been given, which means that, for example, the first activity 1 to 2 can be completed in 6 days at a cost of rupees 60. And we have also been given the minimum time required for completion of the activity after crashing the activity. So for example, the first activity 1 to 2 will take 4 days for completion after crashing. Now after crashing, the cost has increased. So earlier the normal cost was 60 rupees, but after crashing the cost given to us for the first activity is 100 rupees. So similarly we have been given the crash cost for each of the activities along with the crash time. Now we have to draw the network for the project, find the critical path, and then determine minimum total time and corresponding cost. So let's first draw the network diagram. So let's first draw the first node. Say this is 1, and then the second node, let's say this is 2. So this is the activity between 1 and 2. Now next is 1 to 3. So let's say this is 3. The next is 2 to 4, and from 2 we also have 2 to 5. So let's draw these two. So let's say this is 4 and this is 5. So we have completed 1 to 2, 1 to 3, 2 to 4, and 2 to 5. Now the next is 3 to 4. So 3 to 4. So to draw this 3 to 4, I think we should reverse the order. So we should bring 5 here and 4 here. So let's change that. Let's make this 5 and let's make this 4. And then now we can draw 3 to 4. So we have completed 3 to 4. Now next is 4 to 6 and 5 to 6. So both 4 and 5 merge into 6. So we have completed 4 to 6 and 5 to 6, and next is 6 to 7. So 6 and then the ending node, which is 7. So let's add the duration of the activities. So 1 to 2 takes 6 days to complete. 1 to 3 is 4. 2 to 4 is 5 days. 2 to 5 is 3 days. 3 to 4 is 6 days. 4 to 6 is 8 days. 5 to 6 is 4 days. And 6 to 7 is 3 days. So we have completed the network diagram. Now next is to find the critical path. So let's do that. So let's list down all the possible paths. So we have 1, 2, 5, 6, 7. Then 1, 2, 4, 6, and 7. Then 1, 3, 4, 6, 7. So let's now find out the time taken for each of these paths. So the first one, 1, 2, 5, 6, 7. So 6 plus 3, 9, plus 4, 13, plus 3, 16. so 16 days. 1 2 4 6 7, so 1 2 4 6 7, so 6 plus 5 11 plus 8 19 plus 3 22, and last is 1 3 4 6 7, so 1 3 4 6 7, so 4 plus 6 10 plus 8 18 plus 3 21. So this path here, which is 1 2 4 6 7, which is the maximum duration, is the critical path. So we have found the critical path and the duration of the project. So the duration of the project is 22 days. Now next is to determine the minimum total time and corresponding cost. So now we are being asked that if the normal time for completing the project is 22 days, how quickly can we complete the project with all these crash times for these activities, and what will be the corresponding project cost? Now to find the minimum total time, we have to reduce the time taken by the activities on the critical path, because the critical path governs the duration of the project. So first we'll have to identify which are the activities on the critical path, and then we have to identify the activity which has the least cost of crashing, and then we'll crash that activity. Now one thing to note is that there is a very small difference between the duration of these two paths. So this is 22 days and the other one is 21 days. So as soon as we crash the current critical path by 1 day, we get two paths as critical paths. So let's see how we can crash this project. So now one of the most important information that we need is the cost of crashing per day for each of the activities, so that we can find out which activity has the least cost of crashing, and then we can start crashing from that activity. So let's first find that out. So this is cost per day. So the cost after crashing the first activity is 100 rupees, while the normal cost is 60 rupees. So the difference is 100 minus 60, which is 40, and the difference in time is 2 days. So the cost per day is 40 divided by 2, which is 20. For the second activity, the cost difference is 200 minus 60, which is 140, and the time difference is 4 minus 2, which is 2. So 140 divided by 2 is 70. The third activity, 150 minus 50, which is 100, and 5 minus 3, which is 2. So 100 divided by 2 is 50. For the fourth activity, 65 minus 45 is 20, and 3 minus 1 is 2, so 20 divided by 2 is 10. For the activity 3 4, 200 minus 90 is 110, and 6 minus 4 is 2, so 110 divided by 2 is 55. For activity 4 6, 300 minus 80, which is 220, and 8 minus 4 is 4, so 220 divided by 4, which is again 55. So here 220 divided by 4, you can easily divide both the numerator and denominator by 2, so it becomes 110 divided by 2, which is the same as the previous one. So 110 divided by 2 is 55. The next activity 5 6, so 100 minus 40, which is 60, divided by 4 minus 2, which is 2. So 60 divided by 2 is 30. For the next activity 6 7, 80 minus 45, which is 35, divided by 3 minus 2, which is 1. So this again is 35. Now before we start crashing the project, let's first determine the total cost of the project with the normal time. So with the normal time, the duration of the project is 22 days, and the normal cost of performing each of the activities has been given as 470. So the normal cost of the project is equal to 470. Now we have also been given that the indirect cost per day is rupees 10. So what that means is that depending on the critical path or the critical duration, for each day there is an additional cost of 10 rupees. Now with the normal time, the critical path is 22 days. So the indirect cost will be 22 multiplied by 10. So this will add to the normal cost of the project. So 470 plus 22 multiplied by 10. So this is equal to 470 plus 220, which is equal to 0, 7 plus 2, 9, and 4 plus 2, 6. So 690 rupees is the cost of the project using the normal time. So here, in order to crash the critical path, which is 1, 2, 4, 6, 7, let's first identify the activity which has the lowest cost of crashing per day. So the activities on the critical path here is 1, 2, which is this, 2, 4, which is this one, 4, 6, which is this one, and 6, 7, which is this one. So out of these, activity 1, 2 has a cost per day of 20 rupees, 2, 4 has 50, 4, 6 has 55, and 6, 7 has 35. So the lowest is 1, 2, which is 20. So first we'll crash the activity 1, 2 by 1 day, because the difference between the critical path and the next most critical path is only 1 day. So the first step in the crashing is crash 1, 2 by 1 day. So basically, if we crash it by 1 day, the crash cost will be equal to 20 rupees, and the project duration now will reduce by 1 day. So the project duration is now 21 days. So this is now 21 days. So here, if we take a consideration of all the paths, and if we have crashed activity 1, 2, basically this path here 1, 2, 5, 6, 7 will also reduce by 1 day. So this will become 15 days. So now we have two critical paths. One is 1, 2, 4, 6, 7, which is 21 days, and the other one is 1, 3, 4, 6, 7, which is again 21 days. So let's identify the activities which we can crash. Now in this situation where we have two critical paths, we have to ensure that we have crashed the activities in such a way that the duration for both the paths have reduced. For example, say we crash activity 1, 2. Now if we crash activity 1, 2, the path 1, 2, 4, 6, 7 will have a reduced duration. However, the path 1, 3, 4, 6, 7 will still have 21 days. So that means that the project duration has not come down, which is defeating the entire purpose of crashing. So here let's identify which are the combination of activities between these two critical paths which need to be crashed. So if we crash 1 2 from this path, we need to crash either 1 3 or 3 4. Why is this so? Is because 1 3 and 3 4 are not common activities between these two paths. If we take a combination of 1 2 and 4 6, then 4 6 is also present in the path 1 2 4 6 7. So that will also not be an equal crashing of both the paths. So the combinations are 1 2 1 3 or 1 2 3 4. The next one is 2 4 1 3. So 2 4 1 3 or 2 4 3 4, or now the remaining activities are common, so 4 6 or 6 7. So 4 6 and 6 7. So let's find out the crash cost for these combinations. So 1 2 is 20 and 1 3 is 70. So 20 plus 70 is 90. So this is 90. 1 2 is again 20 and 3 4 is 55. So 20 plus 55 is 75. 2 4 is 50 and 1 3 is 70. So 50 plus 70 is 120. 2 4 is 50 and 3 4 is 55. So 50 plus 55 is 105. 4 6 is 55 and 6 7 is 35. Now out of these, the lowest cost of crashing is for activity 6 7, which is 35 rupees per day. So let's crash the activity 6 7. Now 6 7 we can crash only by one day. So the normal time is 3 and the crash time is 2. So we can bring this 3 to 2. So let me quickly denote what crashing we have already done. So we have brought this down to 5 and now we'll bring this down to 2. So here we are crashing activity 6 7 by one day. So this was first and this is second. So for this, the crash cost is equal to, so one day, so 35 rupees, and the project duration is now 20 days. So this has now become 2. Now we reduced the time of activity 6 7. So all these three will reduce by one day. So this is now 14, this is 20, and this is also 20. Okay, so now the third crashing. So again we have the same two paths as the critical paths. So again we have the same combinations. Now we have already exhausted the crash time for activity 6 7. So this is gone. Now the next lowest crash cost is for activity 4 6. So this is the activity 4 6. And The number of days that we can crash this activity for is 4 days. So 8 is the normal time and crash time is 4 days. So now let's confirm if we can crash this activity by 4 days and still not have the critical path changed to a different path in between. So these two paths have duration as 20 days and the other one has 14 days. So even if we reduce these two paths by 4 days, it will go down to 16. So still this other path, which has duration of 14 days, will not be a critical path. So we can continue with the crashing of activity 4.6 by 4 days. So third crashing is crash activity 4.6 by 4 days. So the crash cost is equal to, so 4 multiplied by 55. So 55 multiplied by 2 will be 110 and 110 multiplied by 2 will be 220. So the cost is 220 rupees and the project duration will be equal to 20 minus 4, which is 16 days. So we have crashed this activity and brought it down to 4 days, and our duration of the paths is 14 because 4.6 is not in this path. Now the path 1 to 4, 6, 7 gets reduced to 16 days, and so does the path 1, 3, 4, 6, 7. So this is now reduced to 16 days as well. So this is no longer available. Now since we have the same two paths as the critical paths, let's find out the lowest cost of crashing. So this 75 rupees seems to be the lowest cost. Now this means that we have to crash both 1, 2 and 3, 4. Now 1, 2 has already been crashed by 1 day, and now the crash time available is 1 day, and for 3, 4 we have 2 days available. Now we have to crash the combination of the two. So the minimum common time between the two activities is 1, which can be used for crashing. So let's crash activity 1, 2 and 3, 4 by 1 day. So fourth is crash 1, 2 and 3, 4 by 1 day. So this will become 4 and this will become 5, and the cost is 20 plus 55, so 75. So crash cost is equal to 75 rupees, and the new project duration is equal to 15 days. So now 1, 2 is available in the first path, so this goes down by 1 day to 13 days. 3, 4 is not available on the first path, so that remains unaffected. For the second path 1, 2, 4, 6, 7, 1, 2 is available, so this becomes 15. And for the third path 1, 3, 4, 6, 7, 3, 4 is available in this path, so this becomes again 15 days. So now again let's find the critical path. So again both these paths are critical. So now let's take the same combinations So this one is now not available. Now let's find the activity which has the next lowest cost of crashing. So that is 1, 2 and 1, 3, which is 90 rupees. But now 1, 2 has already been completely crashed, so we can't use this. So this is not available for crashing. Now the next lowest is 105 rupees, which is 2434. Now 24 can be crashed by 2 days and 34 can be crashed by 1 day. So let's crash 24 and 34 by 1 day. So let me put it here. So this is the fifth crashing. So crash 24 and 34 by 1 day. So the crash cost is equal to 105 rupees and the project duration now becomes 14 days. So 2-4, so this has been crashed by 1 day, and 3-4, this has also been crashed by another 1 day. Now this path 1, 2, 5, 6, 7 does not have either 2-4 or 3-4, so the duration remains the same. 1, 2, 4, 6, 7 has 2-4 there, which has been crashed by 1 day, so the duration becomes 14 days. The next one 1, 3, 4, 6, 7 has 3-4 and 3-4 has been crashed by 1 day, so the duration again becomes 14 days. So now again for crashing this project, let's find out the critical path. So again the same paths 1, 2, 4, 6, 7 and 1, 3, 4, 6, 7 are critical. So now let's find out which other combination of activities can be crashed. So this one is now no longer available, so we have already used activity 3-4 to its entirety, so we can't further crash activity 3-4. So this one is also out of question now. Now the next activity which is remaining is 2-4-1-3. So 2-4 can be crashed by 1 day and 1-3, and 1-3 can be crashed by 2 days. So now let's crash activities 2-4 and 1-3 by 1 day, because 2-4 can only be crashed by 1 day. So sixth is crash 2-4 and 1-3 by 1 day. So crash cost is equal to 120 rupees and project duration will be equal to 13 days. So here the second path has the activity 2-4, so this goes down to 13 days, and the third path, this 1, 3, 4, 6, 7 has the activity 1-3, so this goes down by 1 day as well. So now this has been reduced to 3 and 2-4 has also been reduced to 3 days. So now for the next crashing, basically we now have 3 paths, or all the paths which are on the critical path. So if we have to crash, we have to crash all the 3 paths to reduce the time. Now let's evaluate the first path. So first path is 1, 2, 5, 6, 7. So activity 1, 2 has already been completely crashed, so we cannot crash this activity. Activity 2, 5 still has 2 days that can be crashed. So there is scope there. 5, 6 still has 2 days, and 6, 7 has already been crashed. So there is definitely some scope for crashing the path 1, 2, 5, 6, 7. Now let's look at the next path 1, 2, 4, 6, 7. So 1, 2 has already been completely crashed. 2, 4 has been completely crashed as well. 4, 6 has also been completely crashed, and 6, 7 has also been completely crashed. So basically this path we cannot crash any further. So the duration of this path will always remain 13 days. So what that means is that even though we reduce the duration of the other paths, we will not be able to reduce the duration of this path, and so this is the maximum we can crash the overall project to benefit in terms of the reduced timelines of the project. So now there were two questions which we were asked. I'll just make some area here. So the two questions were: determine the minimum total time and the corresponding cost. So the minimum total time is 13 days. Now the cost of the project will be equal to the normal cost which is the addition of this cost plus the crashing cost, which is the cost that we found here. So 20 plus 35 plus 220 plus 75 plus 105 plus 120 plus the indirect cost. So we were given that the indirect cost is 10 rupees per day for the project. So let's find this out. So normal cost is 470, which was given to us earlier, plus the crashing cost. So 20 plus 35 is 55, plus 220 is 275, plus 75 is 350, plus 105 is 455, plus 120 is 575. So 470 plus 575 plus the indirect cost is 10 per day, and the reduced duration of the project is 13 days. So 10 multiplied by 13. So this is 470 plus 575 plus 10 multiplied by 13. So let me pull my calculator here. So 10 multiplied by 13 is 130 plus 575 plus 470. So this is equal to 1175. So the total cost of completion is 1175 rupees, and the minimum total time is 13 days.